Okay, we have been discussing the concept of integration, and I said that integration is actually the reverse process of differentiation. Now, in my videos, I discussed how we can integrate polynomials. You remember, we can have 0 to 1, maybe x squared plus x dx. And I said this is just a review. I said you simply increase this by 1 and repeat this as a denominator. The same thing here, you increase this by 1 and have this from 0 to 1, and you have x cubed over 3 plus x squared over 2. This is from 0 to 1, and that will give you, substitute 1 into this, that will give you 1 cubed over 3 plus 1 squared over 2, and if we substitute 0 into this, you have 0 cubed over 3 plus 0 squared over 2. That might sound crazy because everything is 0. So the only thing we are talking about here is 1 over 3 plus 1 over 2, which will simply give us 6, and here you have 5. So square unit if you want to do that. Very, very important, and that was a basic concept I did in one of my videos. I also said you can have something like this, sine x plus cos x. You can also integrate this with respect to the x, and this will give you integral of sine x is minus cos x, and integral of cos x is sine x, and you just have that plus c as the answer. Why is it plus c? Because this is an indefinite integral. Well, this is just a review. That's not what I'm going into. I want to actually consider the application of this concept, the application of this. So let us see where we can apply this concept. You can always rewind and pause to see how I did that. All right, so we want to take a situation whereby we have a curve, the curve x equals to 4 minus y squared. That is a curve, and we want to look at the curve at the point y equals to minus 1 and y equals to 2. So let us look at the curve. We want to apply this. When you substitute x as 0 here, you're going to have plus and minus 2. So this is going to be 2. This is going to be minus 2. And this is going to be passing through the point 0, x as 0. This is going to be 2. Sure. So the point, at this point you have 0. So if you substitute x as 0, you are going to have this to be 2. If you substitute this as 0, this is going to be 4. Sorry, this is 4. No, this as 0, x is going to be 4. Sorry. So we want to find the area under this curve. I told you earlier on in my video that integration is applied in this plane to find the area of this curve. So if I want to find the area under this curve from the point, let me say from the point y equals to minus 1, I want to find the area, this area, I want to find the area under this curve. All I need to do is to apply integration. So area under a curve A is actually equals to integral from the point A to B of the function of the curve itself with respect to dx. But this curve function you can see now is a function of y. So the area under this curve is going to be from minus 1 to 2, and this is going to be f of y. In this case, you're going to be having the function there 4 minus y squared dy. So we are going to integrate with respect to dy, not with respect to dx this time. So this would have been applied when we have a function of x, but this is a function of y. So we have a function of y, 4 minus y squared, and we have dy. Let's see if we can integrate this very fast. this is going to give us 4y minus. So if you integrate 4, it gives you 4y, and if you integrate this, it's going to give you y 2 plus 1, which is 3 over 3, from minus 1 to 2. So that is going to give us, so we substitute 2 in this, we have 4 into 2 minus 2 cubed divided by 3, minus, we'll substitute minus 1, that is 4 into minus 1 minus 1 cube over 3. So let us do the simple arithmetic very fast. This is going to be 8 minus 8 over 3. I'm sure you're okay with algebra. If not, check some of my video on algebra. And this is going to be minus 4, and this is going to be minus 1. So this is going to be plus 1 over 3. And that will give me 8 plus 4. That is 8 plus 4 here. And I'm going to have minus 8 over 3 minus 1 over 3. And that is going to give me 12 minus. This is going to be minus 9 over 3, which is 3. And that's going to give me 9 square units. I want you to appreciate the beauty of mathematics, that without using a tape or any geometrical object, I can actually find the area of this curve. You see, in this case, I even drew the curve itself. But in some cases, without having to draw this, I can actually find the area under that curve. That is a very wonderful thing in mathematics. Let us just solve one more question where we apply this simple concept. So in some cases, you I need to explain this. Sometimes I'm going to put away this question. In some cases in mathematics, it is possible for me to have one curve here and have another curve here. I can actually find the area between these two curves. So if this is the y-axis and this is the x-axis and this is my origin, and this is f of x and this is g of x, and these points can be traced to the point B on the x-axis, and these points here can be traced to A on the x-axis. Now I want to know what is the area between these two curves. What do? I simply find the integral from A to B of f of x minus g of x, and I've done that with respect. First part of the video, I proved that if we have this axis, this is the y-axis, this axis, let's look at the plane for now, and I have a curve, then the area under this point, if this is A and this is B, is simply the integral from A to B of f of x dx. All right, so but it all depends. Sometimes you can have a curve like this, and this is x-axis, this is my origin. It is possible for you to have a curve here and now have another curve here. It is very interesting that if I know the bound of this place, let's say this is B and this is the bound of this place, and let me call it A, I can find the area here of this strip or whatever shape you can think of. So I can find the area here. And how do I find the area of this point? All I need to know is, what is this curve here? This curve is actually f of x, and I ask myself, what is this curve here? And I know that this is g of x. Once I know what this curve is, and I know what this curve is, the area here is simply the integral from this point A to this point B, which I call the limit of integration of f of x minus g of x with respect to dx. That's all I need to do. So it's not every time that I will be given a single curve like we did in the first part of the video, but you can also have a case where you have to subtract these two, g f of x and g of x, and you have them this way. So let us bring a very interesting example on how this can be tackled. So how do we tackle that? So suppose that we have a case where y is equals to x squared, a parabolic curve. So let us imagine, please, I'm going to give a curve, but that's not the exact curve anyway. So just pardon me for now. So this is my y and this is my x. I'm not doing the actual curve sketching here. So I'm just giving something for you to think of. So this is a parabolic curve, and let me call this y equals to x squared. So imagine that this is a parabolic curve, and now imagine y as 5x minus 6, another curve, which you know, obviously that's a straight line with the slope 5 and the intercept at minus 6. So I can have something like this. This is minus 6, and I want to know what is here, and I also want to know what is here, so that I use that to measure this area. So I can find this area. All I need to know is to measure this point and know what is here, and also know what is here. Once I know these 2 points, the point here and this point here, I can use that to find the area here. And how do I do that? I do that by saying, by equating these two to know the point of intersection of this straight line and this curve. How do I find the point of intersection? I equate these two by saying x squared equals to 5x minus 6, and this will give me x squared minus 5x plus 6 equals to 0. So solving this, I'm going to have my a is 1, my b is minus 5, and my c is equals to 6, so that my x will be equals to 5 plus or minus the square root of 25 minus 4 times 1 times 6 divided by 2 times 1. I'm solving this very fast will give me 5 plus or minus 25 minus 24, which is 1 over 2, and that will give me two values, and that is 6 over 2, which is 3, and 4 over 2, which is 2. So I have my values to be 3 and 2, the point of intersection. So it's very obvious that this point is going to be 3, and it's very obvious that this point is going to be 2. So you see the very interesting part there. So this point is this, and this point is this. So all I need to do is to find the area. The area now will be from where? From 2 to 3. So it's from 2 to 3, and I have my f of x as this, and so it's going to be x squared minus 5x. It's going to be x squared. That is my f of x. And my g of x is this other curve, which is minus 5x minus 6. So this is going to be with respect to dx, and this is going to give us this from 2 to 3 of x squared minus 5x plus 6 dx. So all I need to do is to integrate this using that method I used in the beginning. I'm going to do that here, and that is going to give me x cubed over 3 minus 5x squared over 2 plus 6x from where to where? From 2 to 3. So I substitute the values. I'm going to have 3 cubed over 3 minus 5 into 3 squared over 2 plus 6 into 3 minus that is going to be minus, I'm going to have to take a little part of this out. You can always refer to the part of the video where I started that, and this is going to give me the two parts, going to give me 2 over 3 minus 5 into 2 over 2 plus 6 into 2, and you know that's going to give me 27 over 3 minus 9 times 5, that is 45 over 2. This is going to give me 18 minus, and this is going to give me, oh, I've missed something there. Sorry, I missed this and I missed this. I've put them back. Okay, so this is going to be 8 over 3, and this is going to be 4, and that's 20 over 2, and this is 12. I know you can find the value here and get your answer in square unit. This is going to give us 9. This is going to give us 45 over 2 minus that is going to give us 15 over 2, and can always sum that up to give you your values. Very simple. Arithmetic can be done here with your calculator. That is not really my point. My point is how to tackle this question and have your answer in square units. So this is simply a basic application of integration. And not just only this, it can be applied in so many ways, in volume of revolution, in so many cases, vast cases, you can apply integration. Thank you very much. I'll bring another video, and that is going to be on integration by parts. Thank you.